We're going to go ahead and take a look at factoring and factoring of polynomials. Now, sometimes you can only take out your greatest common factor. That's what the thing or things that go into all the terms that you can pull out. If there's only two terms, you want to check to see if it's a special. Differences of squares, differences of cubes, or sum of cubes. If there's four terms, you want to try factoring by grouping. If there's three terms, we're going to use the idea of AC factoring, sometimes referred to as the British form of factoring. We'll get to the details of that one later. So, looking at this, we are asked to factor what we have here. The first thing you want to do, no matter whether there's two terms, three terms, or four terms, is you always want to look for a greatest common factor. If you do have two terms, three terms, or four terms, and it ends up being a special or grouping or something like that, it's still going to be a lot easier if you take out that greatest common factor. So that's what we're going to look for first here. Is there anything that we can take out of all three of these terms? Well, looking at the numbers, we have a 10, a 15, and a 5. Well, 5 goes into all those. And then when you look at what we have up here, they all have a's. Now, an a cubed doesn't go into all of them because there's only an a squared here and an a to the first here. So we could take an a out of all of these. You'll notice they all have b's, and we could take a b to the first out. So we'll pull out a 5ab, and then we got to look at what's left in parentheses. 5ab times what would give me this here? Well, 5 times 2 is that 10. A times what is a cubed, and that's an a squared. And then a b times another b is our b squared. And then we do the same thing. 5ab times what gives us the next term? Well, that would be a 3 with another a, because a times the a is a squared, and b times what is b? Well, 1, so we don't need to put anything. And then 5 times what is 5? Well, that's 1, so we don't have to write it. And a times what is a? That's 1, we don't have to write that. And b times what is b cubed? And that is a b squared. So this is what we get. Now, sometimes when you are doing these, what's left in the parentheses will factor farther yet. In this case, it doesn't. So we're done with that problem. Over here, we have four terms, so we want to try factoring by grouping. But once again, you want to go ahead and check. Do I have a greatest common factor? Well, they don't all have x's, and 2, and 10, and 5, and 1. Well, there's nothing we can pull out. With factoring by grouping, you want to go ahead and say, okay, I'll group the first two together. What can I pull out of the first two? Well, the greatest common factor of the first two is just an x squared. So you pull an x squared out, and you look at what's left. X squared times what is x cubed, and that's an x. X squared times what is a 5x squared, and that's a 5. And then you want to look at what can you pull out here. You'll notice they're both negative, so I'll pull out a negative, and a 2 goes into 10, so I'll just pull out a negative 2, and that leaves me to the 5 plus an x. Now, you notice both of these parentheses are the same. If both parentheses are the same, we're on the right track. But we're going to make a side note here. Now, when you look here, what can you pull out of both of these, or the whole thing? And well, most of you will say, yes, I can pull out an a. So you pull that a out, and then you're left with an a squared minus 2. What can you pull out down here? Most of you will say, well, triangle's in common, so I could pull out my greatest common factor of triangle. And you're left with an x squared minus 2. Well, what we have down here is really similar to what we have up here. Down here, we had x squared times mumbo jumbo minus 2 times that same mumbo jumbo. So we pulled out mumbo jumbo. That's exactly what we have here. We have x squared times mumbo jumbo minus 2 times that same mumbo jumbo. So we're going to pull out that common factor, which is here in the green parentheses. So we're going to pull out the parentheses of an x plus 5, and then what's that going to leave us with? It's going to leave us with the blue when we factor that out, just like pulling out our triangle down here. And so then we would get this. Sometimes when you get to this step, one of the parentheses will factor farther yet, so just be aware of that. So go ahead and try to quickly do these two and then watch the video. We'll pull out our greatest common factor, which is just an x and a y squared, leaving us with a 6x cubed plus a 9x minus a 1. Over here, there's no greatest common factor, so we'll factor by grouping. The first two, we pull out an x squared. The last two, we're going to pull out a 4. You notice both parentheses are the same. That's really like having a common factor. So we're going to pull out the common factor of the green. So we pull out the green. What's that leave us with? It's going to leave us with the blue. Factoring these, we're still going to go ahead and look for that greatest common factor. You'll notice on this one here, greatest common factor, 3 goes in and x goes in. So we're going to pull out a 3x. We'll pull out that 3x, and that's going to leave us with an x squared minus 4. Now, this ends up being one of the specials in the parentheses because it's a x squared minus a 2 squared. In other words, it's our differences of squares. Differences of squares factors into this here. So we had box squared minus triangle squared, so whatever box is goes in the beginning of your parentheses. Whatever's being squared at the end goes in the end of the parentheses. One of the signs is plus, one of them is minus. So we're going to still have to have that 3x in front. Then we're going to follow this pattern down here. We'll put an x down in the beginning of each parenthesis because what's being squared in the beginning is x, so that goes in the beginning. What's being squared at the end is 2, so we put a 2 in the end of each one. And then one of the parentheses is plus, one of them is minus. Doesn't make a difference which one. Top right here, there is no greatest common factor. However, we have two terms, so we want to see if it's a special. Now we have cubes here, and we have a plus. So it's possible it'll be sum of cubes down here. But let's write it in this form. What's being cubed in the beginning? Oh, well, and what's being cubed is an xy. That's all being cubed. What's being cubed in the end? Well, that's a 2 that's really being cubed. And I notice I have a mistake here, so just a second. So it does end up being something cubed plus something cubed, so it matches with this. So whatever is being cubed, that's in the beginning, that's where we put in for our boxes here. Whatever is being cubed at the end, that's what we put in for our triangles. So what's being cubed in the beginning is an xy, so I'm going to put an xy in for all those boxes. What's being cubed at the end is just our 2, so I'm going to put a 2 in for all those triangles. Now, sum of cubes and differences of cubes are factoring in a very similar way. Notice with differences of cubes, the first sign is difference. Sum of cubes, the first sign is a sum. The second sign is always opposite the first parenthesis, and the last sign is always positive. So we'll go ahead and simplify this just a little bit. Now some people when they're doing this, they'll forget to put the parentheses around this xy, so they won't have the squared apply to the whole thing. But it does apply to the whole thing. Typically it's common practice to put your number in front of your variable, so we'll put the 2 here, and then we'll square what the 2 is, and then we get 4. So that's our sum of cubes. So go ahead and try to factor this one here. So following the sum of cubes, we end up getting something like this. So I would encourage you when you're factoring sum of cubes and differences of cubes to not just look at this line right here, but rewrite it as something cubed plus something cubed. That's going to allow you to be able to plug stuff into your formula correctly.